This session is on Mathematics, Chapter 1 on Real Numbers for Grade 10, Exercise 1.2, question numbers 4 and 5. Question number 4 says, given the HCF of 306 and 657 is equal to 9, find the LCM of these same two numbers. We know that HCF of A and B when multiplied by LCM of the same numbers A and B gives us the product of the same two numbers A and B. Now we are given two numbers 306 and 657. We are given that HCF of these numbers is 9. So it's very easy for us to find the LCM, which will be found by using this equation where it says that HCF multiplied by LCM is equal to the product of two numbers. So in our case, LCM of the numbers 306 and 657 will be 306 multiplied by 657 divided by the HCF of these two numbers, which will be equal to 201,042 divided by 9, which will be 22,338. Hence, we can say that the LCM of 306 and 657 is equal to 22,338 as our answer. Let's now solve the question number 5, which says check whether 6 raised to power n can end with the digit 0 for any natural number n. So we know that if the number 6 raised to power n were to end with the digit 0, then it would be divisible by 10. We also know that 10 can be prime factorized as 2 multiplied by 5. That is, the number 6 raised to power n, if it were to end with the digit 0, then it would be divisible by 5 and 2. In other words, prime factorization of 6 raised to power n would contain prime numbers 5 and 2 if 6 raised to power n were to end with the digit 0. And let's call this as our statement number 1. Let's see also that 6 raised to power n is equal to 2 multiplied by 3 whole raised to power n, which is equal to 2 raised to power n multiplied by 3 raised to power n, which gives us that the prime factors of 6 raised to power n are 2 raised to power n and 3 raised to power n. And let's call this as our statement number 2. From statement number 2, we see that the prime factors of 6 raised to power n do not include the prime number 5. But in order to end with the digit 0, the prime factorization of 6 raised to power n must contain number 5. And this is what we have found from our statement number 1. So we can clearly say that 6 raised to power n cannot end with the digit 0 for any natural number n.